Hey, what is up guys? Sean here. In this video, we'll cover using verse persistence and update our stats board made in this video to use persistence. Before we continue, I'd like to thank all my supporters over on Patreon. Huge shout out to you guys. Thank you all so much for the support. I appreciate each and every one of you. All right, with persistence, we can track multiple stats. In this example, I'm tracking kills, deaths, KD, headshots, and score. You'll see here I have a tracker for score and a tracker for headshots. The tracker for headshots is set to 1 and resets every time you get a headshot on a player and increments the score by 15 and kills give 5 points. In the scoreboard, you would see a section for score because we're using a tracker for the score. We're not using a tracker for eliminations and eliminated because the scoreboard tracks those natively. And so we can see that anytime you get a kill, it goes up by 5. And a headshot goes up by 15 points. When you get eliminated, the points are reduced by 2, and you can set this to, whatever you want. And so we'll end the game, and then when we load back in, it should be the same score as when we left. And as you can see, it is score 46, and I am in the platinum rank. And so when I get eliminated by another player, you can see their score goes up and mine goes down. A lot of you guys wanted to see how you would update the stats board for multiple players, especially in your 1v1 rank maps. This video should cover how to do that. Next, we'll go over the UEFN settings and code. So the first one we want to use is a material. You can see here, this is the material that we're making, and we'll go over how to make that right now. This is the texture that we're going to use. It's texture that has 6 rows and 3 columns. Each row has the rank going from 0 all the way to 17. And this is so we can use a flip book to determine the position of the UV to display the image. And so we want to right click, create a new material, call it M rank player 3 for this example. Inside this, we have the material. We want to make sure it's set to surface and translucent. You can use translucent or masked. It doesn't really matter. You just have to make sure opacity for your image is set to the correct opacity node here. So we'll go back to translucent. We want to get the texture sample. So hold T on the keyboard and left click to bring up the texture sample. Click on the texture and look for the rank icon. You can find this online or make it yourself. I made it in Photoshop. And then connect the RGB to the base color of the material and then the alpha to the opacity. And there you can see the icons in the detail window on the left. And now we want to use a flip book. If you right click, search for flip book, you should see a flip book material function. Connect UVs to UVs. And then here we want to set the number of rows and columns based off of our texture image. So remember, we have 6 rows and 3 columns. To get a constant node, hold down the 1 key and press the left mouse button. And again, to get constant nodes, connect the constant nodes to columns and number of rows, and then set this to the number of rows and columns in your image. Here I am using 3 columns, so we put 3, and then rows is 6. So now we have a flip book that'll go through the UV position on the texture and show the appropriate ranked icon. In order to control this, we're going to need a material parameter collection, and we need to do some math. Press M on the keyboard to bring out the multiply node. Multiply these 2 values together, and then you want to hold down D to get a divide. Plug this output of the multiply into the divide, and then we want to get a parameter collection for the value we want to change. So if you right click, search for collection, it makes a new collection there. Click on the collection, create a new material parameter collection, select your folder, and you can call it MPC rank P3. Double click the parameter collection, add a new element, inside the element, call it rank, and leave it at 0 and click on save. You can close out of that. And then we want to multiply this value by the output of the divide node and plug that into the animation phase. Before we do that, click on the parameter collection and set the parameter to rank. Press M for a multiply node. Connect that output to this output and the output of that into the animation phase. And now you should have the bronze icon selected. Now, if we control the parameter collection by setting it to 17 and saving, it should show the Unreal icon. So this is what we're going to animate using a level sequencer to display the rank of the player. So we'll click on this, set it back to 0, save, and now you have the material to place on your creative prop. We save, exit. So we have material rank P3 here. The next thing we want to create is a data asset. Data assets are good because they will prevent your creative prop material from breaking if it does get damaged by, let's say, bullets or a pickaxe. Right click, go to miscellaneous, click on data asset, and then select building texture data. Click on select, name it data asset rank P3. Inside the data asset rank, we want to select the override material with the material we just made, which is M rank P3. And then click on save. For the data asset, you can then apply it to your creative prop. I'm using a plane here, but usually my default is agency embossed wall. You can bring that up. Select the data asset, data rank P3, and if it looks weird like this, just rotate it and you should have your icon. And now you can scale it to the size you need. So 0.5, 0.001, and then 0.5. And now you have the same texture here. So, yep, embossed agency wall will get you what you need. We'll just delete this so we don't need it. Inside the stats board, the next thing we want to create is a level sequencer so we can animate the rank icon based off of keyframes. So if we select the rank icon, we can set this to the data asset we just created, call it data asset P3. Next, right click, go to cinematics, create a level sequence, ls rank P3. Now you'll notice I have 2 of each. Most of you are looking for, your ranked 1v1 matches. Setting up a billboard for 2 players is so you can set it up in your ranked 1v1 matches. Each player needs their own data asset, material, level sequencer, and material parameter collection so you can animate it for each player. So here we'll create a cinematics level sequence. Here we want to add the material parameter collection track MPC rank 3. That's the new one we just created. Then we want to click on the plus and select the scalar value rank. You can drop down this arrow and there's already a keyframe here at 0. And then we want to make sure that this is set to seconds. So if you click on the FPS button, show time as seconds, and you can see the animation sequence in seconds. At the bottom here, go to 17, press enter, press the set playback to end to the current frame, and then add a keyframe and set this to 17. And now for each second, you want to set the keyframe from 16 and the rank to be 16 to match up with each second. So if it's 15, go there, set it to 15, 14, set it to 14. This ensures that the animation that we set in the code matches to the rank icon that we want to show. Now, I'm not going to do this for the rest of it, but you get the idea. Set it from 0 to 1. Now, it looks like it's interpolating the frames based off of what we set, but if you want precision, just go through and mark all the keyframes. Once that's done, click on Save, and then you should have the level sequence that you need created. And that should be it for the assets. The next thing is plugging them in to the creative device. And then we'll cover the code and how to set everything up. In the creative device, you have the player spawners for the 2 players, the headshot tracker, the score tracker, the billboard for player 1, which is this, the player reference for player 1, and the icon for player 1, and the sequencer for player 1, and then the same thing for player 2, the billboard, the reference for player 2, rank icon for player 2, and the sequencer for player 2. For the sequencer for player 1, make sure it has sequence rank for player 1, loop, playback, false, false, everyone, force keep state. And then same thing, just make sure the rank is set for player 2, or the cinematic sequencer is for player 2, not player 1, and visibility for everyone. For the headshot tracker, it's set to eliminations, target values only 1, sign on game start true, true. If you don't want to display it, just set these to default empty. On complete, you want to do nothing. And show on HUD, show progress off. And so in the code, anytime this is reached, we just reset it so that we can keep tracking headshots. For the score tracker, kind of similar. We just set it to the max value, starting value 0. You can remove these, set it to empty. And on completion, do nothing, show HUD progress off. And I am not using persistence because we're doing all this stuff in verse persistence. And that's it for the creative devices and UEFN setup. Let's go to the code. All right, here's the code. We have a persistable data class that has the specifiers final and persistable. Epic recommends using a version number so you can force changes based off of the version number. And the stats are here. We have the persistable data map, which takes the player and the player stats. And so this is where if a player has saved data or any persistable data, it will be stored here. We have a constructor used to make partial updates, such as a constructor specifier, transact specifier. We can make partial updates to the class that we set up earlier. In the custom player class, we have a few fields that are required upon creating a new custom player. That is the agent, player, billboard device, cinematic sequence device, and a tracker device. In the init function, we call the load save data function and the update billboard function. In load save data, we check to see if the player has any saved data in the persistable data map. If they do, we get their score and update the tracker value to that score and then update the billboard. If they do not, we set the new player key to the new persistable data map. In update billboard, we get the player stats and then we get the rank based off the score. We then update the billboard with the kill death ratio and set the text using one billboard. Here we're just setting everything on a new line and then we update the frame for the rank icon. In get stats, we check to see if the player has persistable data. If they do, we return the player stats. Increment kills, we are getting the old data based off of the persistable data map and then using the constructor to increment that value by 1. And so here is where we're making use of the constructor to partially update kills for this player. When we do that, we then increment the score by 5. We do the same for increment deaths. If a player dies, we increment death by 1, and then we decrement the score by 2. Same for headshots. We increment score by 15 and incrementing headshots by 1. Inside increment score, we take the score of the tracker and add that to the added score and then update the billboard. And we're doing the same for decrement score and subtracting the score. Reset stats isn't being used right now, but if for some reason you wanted to reset a stat that you're tracking for a player, you would do that upon player initialization. So you would call reset stats inside here. So here is where you would call reset stats if you wanted to reset the player stats for some reason. Set frame, we're setting the sequencer playback time to the rank times 1 to convert it into a float. So inside get rank basically returns an index based off of the rank. If you remember, the rank image goes from 0 to 17, 17 being unreal and 0 being bronze 1. And so we take that and set it to the sequencer playback time. Then we're playing the sequencer, then we're spawning pause frame, sleeping, and then pausing the animation. Then respawn, just an instant respawn function. You have your localization functions here, string to messages and agent to messages. I'm currently only using the string to message function. Inside the StatsBoard creative device, you have the general game devices, player spawners, the headshot tracker, and the score tracker. You have your player 1 devices, billboard, reference, the rank icon, the sequencer, and for player 2 devices, the same thing. We have a map to store custom players based on the agent key value. On the unbegin function, we get the player 1 spawner and the player 2 spawner, and then we subscribe to the on player spawned event, and we're subscribing to the complete event for the headshot tracker. On player 1 spawn, we're calling the function init player, which takes in an agent, billboard for player 1, and sequencer for player 1. We register the player on the player reference device. We show the rank icon, and then for player 2, doing the same thing. On the headshot callback, check to see if the player's in the player's map. If they are, we call the increment headshot function on the custom player class, and then we reset the tracker for the agent. On the init function, if there is a player, we do nothing. If there isn't a player, we create a new custom player and pass in the agent, the player, the billboard, the sequencer, and the tracker, and then we update the player's map with that custom player. Then we call the init function and subscribe to the player eliminated event. On the player eliminated event, we are just updating the billboard and incrementing kills based off of the agent who did the killing and the agent who was eliminated. Update the billboard and increment the deaths. On the get rank function, we covered this before, but you can update these values here for the score to determine the range you want your ranks to go for. On the get rounded function, it just rounds a float to a certain number of decimal places. And that's it for the code. I recommend reading Epic's documentation on persistence. Links will be in the description, but here's a summary. Rolling back your island in the creator portal will reset persistable data for all users. If a player with persistable data for an island load fails, the player will not be able to join the island. This seems like a big deal as it could prevent people from joining your map. I don't know the details of what causes this failure, but my guess would be if a player reaches the maximum data limit, so you should prevent this in your code by capping the values of each player, or if you update your persistable class and something is not supported. Classes are the only type of data that can change after a map has been published as long as they have default values. Use a version field in your class to detect changes. It gives you flexibility if your logic changes over time. Data that exceeds the size limit will get a verse runtime runtime error. A weak map record has a maximum data size of 128 kilobytes per player. That is 12,000 float or int values or 100,000 characters of text. An island can only have 2 weak maps with a player as the type. As always, all files, assets, and code can be found in my Patreon in the description below. Make sure to join the Discord and become part of the community. Big updates coming soon. Also consider using creator code shaanprime in the item shop. Thanks for the support. If you enjoyed the video and found it helpful, make sure to like and subscribe. I'll see you guys next time.